This is the final lesson in this session, and we're going to add a sweet reverb.
Totally, bro.
To our polyphonic synthesizer. While we could do this by connecting the output of the current synthesizer to a reverb circuit directly in the process line, this would be highly inefficient as the reverb will be duplicated for each voice. Fortunately, a global audio effect can be applied to all the polyphonic voices at once by defining an effect element anywhere in the code.
A good reverb circuit with a simplified user interface is Z-Lite, which can be found in demos.lib library. So we need to use the dm dot prefix before Z-Lite. The number of outputs of a single voice of the polyphonic synthesizer must be the same as the number of inputs of the effect. Since Z-Lite is a stereo reverb, it takes 2 inputs. Therefore, the output of process must be split into 2 signals. This can be easily done in Faust using the split operator, followed by a stereo circuit conceptually equivalent to a stereo cable. We'll provide more details about this type of construction in the next session. So if we look at it here, what we just added in the code is the effect line where the effect is defined. Then we put Z-Lite in the effect, and the output of the process line, which is now a stereo output because we're using split, and the 2 parallel signals here will get automatically connected to the effect that we just declared in here.
As previously, this Faust program could be exported as a mobile application. If a MIDI keyboard were to be plugged into the mobile device running this app, it would be able to control it just like in the web editor.
In this session, we try to give you a taste of what Faust is capable of without going into too much detail. In the next session, we'll dig in the Faust syntax. By the end of it, you should know everything to code pretty much any time domain DSP algorithm in Faust.
See you at the next session.
See you at the next session, Jan.